Hello, it is Mrs. Marquette, and we are starting day 4 of our factor chapter notes. Today there will be 3 videos in order for you to get all of the notes for day 4. And today's going to be an important day because we're actually going to talk about what a factor is. It's the factor chapter. We have been talking that we're in the factor chapter, but we haven't even mentioned what the word factor means. So today we're going to answer that burning question of what is a factor. And to do so, I want you to think back to the last lesson, which is talking all about multiplying polynomials. So we used the distributive property, we were multiplying 2 polynomials, everything was dealing with multiplying. Today, we're just going to go in the reverse of that. So on the top of your notes, it says a factor is a number or quantity that when multiplied with another factor produces a given number or expression. So really, that just means, like, if I have a multiplication problem, like 2 times 3 equals 6, then 2 and 3 are the factors of 6, because those are the things that multiply to 6. So when we talk about numbers or quantities, we'll break them up into factors. What are things that multiply to get the final answer, the final number? So we're going to kind of buzz through these first ones. It says list the factor pairs of the following. So I want to know, like, what are the things that multiply together to get the final number? So in 30, I know that 1 and 30 multiply to get 30. So do 2 and 15, and 3 and 10, and if I keep looking, I think 5 and 6 will also multiply to get 30. And those are my factor pairs. Right now, that's all I want you to do. Okay, I'll do maybe one more of these, and then I'll have you try C through F. Okay, 24. Looking for numbers again that multiply to 24. So I've got 1 and 24, 2 and 12, 3 times 8, 4 times 6, 5 doesn't go into 24 evenly, 6 I already have, so it looks like if I go to 7, that's not going to divide in evenly, but 8 does. I already have 8, so it looks like I'm already going to be doing repeats the higher and higher I go up. So when you find these multiple or these factors of the numbers, you can go ahead and just start dividing the final number by your whole numbers. So divide by 1, 2, 3, 4, 5, 6. And then once you get to the point where you start seeing numbers that you've already used as factors, then you know you've got them all. Okay, I want you guys to go ahead and try C through F. We'll do the ones with variables together, but I'm going to give you like a minute in this video to just go ahead and try that. Okay, so double check your answers on C through F. You'll notice that on D specifically, there's only one factor pair. It's just 1 and 31. Those are actually kind of nice because then I don't have too many options when I'm looking for factors. We call that one a prime number. We call it prime because only 1 and itself are factors of that final number. So this same strategy can work when we're looking for factors of variable expressions. So if I have x, y, the two things that are multiplied together, two variables that are squished up together are multiplied. So my factor pair is x and y, and that's it. Letter H, I've got p times q times r, but if I want factor pairs, I can say this is going to be PQ times R. Those are two things multiplied together. I could even say P times QR. And if I want to go with one more, I could say PR times Q. Okay, because I'm really saying this is one factor times another. This is one number times another. And this is one number times a number, or times another. The last two are the ones that we'll really start getting into throughout this chapter. So here I've got a binomial times a binomial. So two terms times two terms. And this is just like a quantity. If I plug in a number for x, I'll have one number times another number. So my factors are actually these whole parentheses. X plus 7 is one factor, and it's multiplied by x minus 1. And that is going to be what we start seeing is when I have two binomials multiplied together, I call each one of those things factors. So you try J here. Give you just a second. And hopefully you see that J plus 2 and J squared plus 1, those things are multiplied together because they're squished up together. So J plus 2 is one factor, and J squared plus 1 is another factor. Not too hard to see those factors because they're already in parentheses. So here's the point. When we work with quadratic expressions, so ax squared, bx plus c, so things that are like polynomials, it's at times helpful to work with the factored form, which means instead of working with a polynomial without parentheses, I want to work with it when I have one factor multiplied by another. The first thing that we're always going to look at when we're factoring is the greatest common factor. And the greatest common factor is exactly what it sounds like. Greatest is like largest. Factor, we said something that's multiplied. I'm going to call it a factor, and we'll say see above. And then common is in both or in all terms. So it's got to be common to every single term in my polynomial. If you have two terms, then it's got to be in both terms. If you have three terms, then it's got to be in all three terms. And we'll see what that looks like here. So listing the GCF of the following pairs and triples, if I'm looking for the GCF in 15 and 30, I'm saying what is the biggest number that's a factor of both 15 and 30? So I could list out like 15 and 30. What are the numbers that multiply by another number to get 15 or divide evenly into 15? I've got 1, 2 goes into 15 even, or 2 does not go into 15 evenly. I'm crazy. 3 goes into 15 evenly, 3 times 5, and then 15. So those are all of my numbers that divide evenly into 15 or can multiply by another number to get 15. 30, I'm going to have 1, 2 because 2 times 15, 3 because 3 times 10, 5 because 5 times 6, 6 because 5 times 6, 10 because 3 times 10, 15 because 2 times 15, and 30. So now I'm just going to look and say, like, what is the biggest number that those two have in common? And it looks like it's 15 in both. So my GCF is 15. I'll try B, and then you try C. So for 24, we've got 1 times 24, 2 times 12, 3 times 8, 4 times 6, 6 times 4, 8 times 3, 12 times 2, and 24 times 1. And 42, I've got 1 times 42, 2 times 21, 3 times 14. If you need to check that one in your calculator, do it. 4 does not go in evenly, 5 does not, 6 does, 7 does, because 7 times 6 is 42, 8 does not, 9 does not. Really, we can look for what multiplies with 3. We said that was 14. 2 times 21, and then 42. So I'm looking for what is my largest in common. Looks like 6 is my GCF. And you guys go ahead and find C, please. On this one, you might have noticed when you listed the factors of 49 that 1, 7, and 49 are the only factors of 49. So if I think about the factors of 36, 1 is a factor of 36, but 7 does not go in evenly to 36, and 49 definitely doesn't go evenly into 36. So my GCF is actually just 1. And that's okay. That actually happens a lot, that our GCF is 1. So this is a special case to make sure that you're aware of, that when you check a GCF, you could have 1. D, our GCF can also be variables. So here, if I look at the GCF of my numbers, 4 and 3, my GCF there is just 1. Then I look at my x's. They both have an x, so I'm going to say that my GCF is x. It's a factor of both. And then y's, well, I only have one y, so I don't have a GCF for my y's. So I can also say that that's times 1, but 1 times x times 1 is just x. So I'll say that my GCF is just x. Oh, let's see, I'll do f, and then I'll have you guys do the last 3. So this one, I look first of all at my numbers, 2, 4, and 6. The thing that goes into all 3 of those evenly is 2. I can't say that it's 4 or 6 because 6 doesn't go into 2 and 4 doesn't go into 2. I can't multiply 4 by something, a whole number, to get to. So 2 is in all 3. And then as far as x's go, I have an x squared and x. This one does not have an x, so I don't have something that's common to all 3 of those. So I can just say that really, for the x's, it's just 1. I don't have any x's. So 2 times 1 is just 2. Okay, why don't you guys try E, G, and H, please? So looking at E, 5 is a factor of both 5 and 20. They both have an x, so that's part of my GCF, but the second term does not have a y squared, so I just have a 5x as my GCF. For G, 7 is a factor of 7, 7 is a factor of 14, 7 is a factor of 42, so I can say that that's a common factor. And then as far as my y goes, all 3 of these terms have at least one y. So 7 has 2 of them, 14 has 1 of them, and 42 has 3 of them. But they all at least have 1, so we call that our GCF. It's the greatest number that's in all of them. H has a similar thing. 7 and 2 don't have any factors in common, but if I look at x's, both of those terms have at least one x. They both have at least one y, and then they both have at least 2 z's. It's the greatest number of z's in both of them. So my final GCF is x, y, z squared. We can factor to GCF. It's just like the distributive property in reverse. So if I have 3x squared minus 6x plus 18, I'm going to look at all 3 terms, and I notice that 3, 6, and 18 have a GCF, or a greatest common factor. That greatest common factor is 3, because 3 times 1 is 3, 3 times 2 is 6, and 3 times 6 is 18. So what I'm going to do is I'm going to put the 3 on the outside, And I'm going to do the distributive property in reverse, which is multiplying in reverse. So you can kind of think about this as dividing, or you can think about it as distributive property. So I say, what do I multiply 3 by to get 3x squared? And that answer is just x squared, because 3 times x squared is 3x squared. Then I look at the next term. What times negative 6x, or what times 3 gives me negative 6x? Well, negative 2 times 3 gives me 6, and then I also need an x. And then the last term, I say, what times 3 gives me positive 18? And 3 times 6 is positive 18. So that is the factored form. I have 2 factors. I have 3. And then my second factor is this whole parenthesis, x squared minus 2x plus 6. And then if I check it, I can distribute my 3. So 3 times x squared is 3x squared. 3 times negative 2x is negative 6x. And then 3 times 6 is a positive 18. That looks exactly like my original, so I know that I've done it right. My final answer as far as factoring goes is this right here, my factored form. That check is just to make sure that I did it right. All right, now that we've gone through this kind of slowly, I'm going to go through the example problems a little more quickly. So number 1, 5y plus y squared. 5 and 1 don't have a common factor, but I do have at least one y in both of these. So I put my y on my outside. And for the first term, what times y gives me 5y? That's just 5. And then what times y gives me 1y squared is just 1y, because y times y is y squared. I can check y times 5 is 5y, and then y times y is y squared. That looks correct. It's exactly what my original problem was, so that's my factored form, y times 5 plus y. Number 2, I've got 9x squared minus 3x. First of all, I see that my 9 and my 3 have a GCF. That is 3. They both can be divided evenly by 3. Then I look at my x's. Both of these have at least one x, so I also have an x in my GCF. Okay. 3 times what gives me 9 is 3. X times what gives me x squared is x. And then 3 times what gives me negative 3? Well, that's negative 1. And what times x gives me x is also 1. So this final answer is just 3x times 3x minus 1. I can double check. 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. Check. That's exactly what my original problem was. Here we got to be careful because we've got 3 terms. We have a 6y, 12x, and an 8z. What is the number that goes into 6, 12, and 8? If I think about that, well, 6 and 12 would be 6. But if I add in this 8, I can only divide all 3 by 2 evenly. And then I look at my variables. They all have different variable parts, so I don't really have anything in common for any of those. So 2 is my only GCF. 2 times what gives me 6? That's 3, and I need a y. 2 times what gives me 12? That's a 6 and an x. And 2 times what gives me negative 8? That's a negative 4. Oh, and I can't forget my z. Okay, double checking. 2 times 3 is 6. I need a y. 2 times 6 is 12. X. 2 times negative 4 is negative 8. Z. This looks like a good answer because it's exactly works out to be my original problem. Let's try one more together and then I'll have you do the last 2. X to the 4th, x to the 3rd, x squared. Here I have a 1 out in front of my first, so it looks like my number of my GCF is just going to be a 1. And then as far as how many x's are in common, they each have at least 2. So It's going to be a 1x squared. And we know that 1 times anything is just that thing, so I don't really need the 1. So x squared times what gives me x to the 4th? Looks like I need 2 more. And then 1 times 6 is 6. What times x squared gives me x to the 3rd? Well, I need 1 more x. And then what times x squared gives me 8x squared? Well, 1 times 8 is 8. And then I already have all the x squareds I need. So that's as much, or that's as far as I go. Double checking, if I distribute, x squared times x squared is x to the 4th. X squared times 6x is 6x to the 3rd. And x squared times 8 is 8x squared. And that's my final answer. All right, you do those last two, please. So here's what I got for 5 and 6. In the first one, I look at my numbers. 3 is a factor of all 3 of those, and they each have at least 1x, so that's why my GCF is 3x. So let's double check. I get 3x times x squared is 3x cubed. 3 times 9 is 27. X times x is x squared. And 3x times 3 is 9x. Check. That looks like my original. And then on number 6, I do have a common factor in my numbers. Those are all divisible by 4. I have a number that multiplies by them to get 4 by them to get the original. And then 4 times x squared is 4x squared. 4 times 6x is 24x. And 4 times 9 is 36. So again, check. That is a good final answer. So that's what I have for you on greatest common factors. You can watch the next video to see factoring by grouping.